Types of redox reactions. First type is combination reactions. Second type is decomposition reactions. Third type is displacement reactions. And the fourth type is disproportionation reactions. Let's start with the combination reactions. Combination reactions. What are combination reactions? A reaction in which two atoms or molecules combines together to form a third molecule is called a combination reaction. For example, AB combines together and form a third molecule AB. A and B combines together and form a third molecule AB. Okay. All the combustion reactions involving elementary oxygen and all other reactions which involves all elements other than oxygen are combination redox reactions. For example, carbon and oxygen combines and form a third molecule which is carbon dioxide. Methane and oxygen combines, they form carbon dioxide and water. Similarly, when magnesium and nitrogen combines, they form magnesium nitride. So these three reactions are the example of combination redox reactions. So now let's discuss decomposition reactions. What are decomposition reactions? Those reactions in which a molecule breaks down to form two or more components is called a decomposition reaction. And the general formulation is AB is a compound which undergoes decomposition and splits into its components A and B. This reaction is just reverse of combination reaction. If I proceed this reaction in this way, in the opposite direction, AB compound is formed with the combination of A and B. So it is very important point to note down here. All decomposition reactions are not redox reaction. There is a condition for a decomposition reaction to be a redox reaction. It is very essential that one of the product of decomposition must be in the elementary state, which means for a decomposition reaction, whether A or B elements are in their elementary state. For example, water decomposes into its components hydrogen and oxygen. So this is a decomposition redox reaction because the product oxygen and hydrogen both are in their elementary states. In the second reaction, in which sodium hydride decomposes into sodium and hydrogen, this is also an example of decomposition redox reactions because hydrogen and sodium, both elements are in their elementary states. In the third reaction, this is potassium chloride decomposes into potassium chloride and oxygen. Is this reaction is an example of decomposition redox reactions? Tell me the answer in the comment box. This reaction is a decomposition redox reaction or not? Let's move further and discuss about displacement reactions. So what are displacement reactions? Those reactions in which an atom or an ion in a compound is replaced by an atom or an ion of some other element is called a displacement reaction, and its general representation is A, B and C combines together and form AC and B. Observe this reaction carefully. What will happen? The C atom replaces the B from AB compound and B is out of the compound AB. So in the compound AB, the B atom has been replaced by another atom C. So this is the general formulation of displacement reactions. So types of displacement reactions. Displacement reactions are of following two types. First is metal displacement reactions and the second type is non-metal displacement reactions. Let's discuss first metal displacement reactions. These reactions, a metal in the compound is displaced by some other metal in the elementary state. For example, this is a compound of copper sulfate reacts with zinc. Okay, so in this compound, copper is a metal and zinc is also a metal in its elementary state. When the reaction proceeds, zinc displaces the copper and forms zinc sulfate. So in the other reaction, this is vanadium pentoxides reacts with calcium. Now calcium displaces the two ions of vanadium and forms calcium oxide. These reactions are the example of metal displacement reactions. In these reactions, metal displaces by some other metal. Now non-metal displacement reactions. In these reactions, a metal or a non-metal displaces another non-metal from its compound is called a non-metal displacement reactions. The non-metal is mostly displaced is hydrogen. For example, in the first case, alkali metals and alkaline earth metals, they are very good reducing agents. They displace hydrogen from the cold water. As we know, alkali metals are the members of group 1 and the alkaline earth metals are the members of group 2. When calcium reacts with water, calcium displaces the two molecules of hydrogen and forms calcium hydroxide. Similarly, when sodium combines with water, sodium displaces the two molecules of hydrogen and forms sodium hydroxide. In the second case, less active metals such as magnesium and iron reacts with steam to produce dihydrogen gas. Similarly, when iron reacts with water and it displaces the 8 molecules of hydrogen and forms ferric oxide. In the third case, there are many metals including those which do not react with cold water but capable of displacing dihydrogen from acids. For example, zinc cannot react with cold water but react with acid to displace dihydrogen. Zinc react with acid, it is a hydrochloric acid HCl. It displaces two molecules of hydrogen from HCl and form zinc chloride. Similarly, when magnesium combines with HCl, magnesium displaces the two molecules of hydrogen and form magnesium chloride. Let's discuss our fourth reaction, disproportionation reaction. So what are disproportionation reaction? A reaction in which the same species is simultaneously oxidized as well as reduced is called a disproportionation reaction. For such redox reactions to occur, the reacting species must contain an element which has at least 3 oxidation states. For example, the decomposition of hydrogen peroxide is an example of disproportionation reaction where oxygen atom undergoes disproportionation. So here the oxidation number of oxygen in peroxide is decreases from -1 to -2. Reduction of oxygen takes place, whereas oxidation number of oxygen in peroxide is increases from -1 to 0, which means oxidation of oxygen takes place.
viral.